Well there, human beings! Hello, and welcome to Basic Chemistry Explained. Today we'll be talking about atoms. So this is what an atom looks like. Kind of. Well, here we have an electron cloud, a proton, and a neutron. Very neat and very simple. So let us take a closer look at the particles up close. This is an electron. Electrons are found inside the electron clouds, and they carry a negative charge. Those guys really like playing hide and seek, so you really never know where it is exactly. You know it's somewhere there, but not exactly right there. I'll explain that a little later in further detail. And also, since this is the only removable particle that carries a charge, it's the particle that determines the charge of the atom. Again, I'll explain that later in further detail. Also, these are the particles that are involved in bonding, which I'll explain in episode 3. Alright fellows, this is a proton. Protons are found inside the nucleus of an atom, and they have a positive charge. These are the particles that determine the element. So depending on the number of protons inside the nucleus, it's going to be a different element. I will explain elements in further detail in episode 2. For now, I'll tell you that elements are like oxygen and hydrogen and chromium and arsenic, silver, gold, the individual kinds of chemicals. Alrighty, that's a neutron. Doesn't do much, just sits around there, determines the isotope, doesn't have any charge, and it just hangs around in the nucleus all the time. I promised to explain stuff, so it's time to do that now. Alright, so it was probably a bad idea to use round objects for this, but let's just say that this gold bead is a proton and the silver bead is a neutron. And let's make these tiny little white pearls our electrons. And after this short, ridiculous clip of me desperately trying to arrange all these beads into something that at least closely resembles an atom, we can start learning today, guys. Now, the first concept I want to explain is that you don't really know where the electrons are. You know a region where they can be, or they should be there, but you don't exactly know where in that region they are. Let's say you have like pockets where you know you have a certain amount of electrons, but you don't really know, is it there or there or there? You know it's somewhere inside of this pocket. It's like when you have a purse and you put a coin inside of it, but you don't really know where the coin is. It could be here, or it could be here, or over there. You don't really know, it could be even here or here. Until you actually look inside and see, oh, right now the coin is right here. But you can't really do that with electrons. So you really never know where electrons are. So this is how you usually see an atom represented. Just a nucleus surrounded by a bunch of electrons. Well, this oversimplifies things, of course, but it also makes your work easier, and it's easier to think of it this way. Of course, it doesn't really look like this, it's a little more complicated, but it's good enough for now. Ions. They're the best. Let's say you have some atom that has 3 protons in it, and maybe 3 neutrons and 3 electrons. As I've said already, protons are positively charged, and electrons are negatively charged, and neutrons don't have a charge, so we'll ignore them for now. So at this point you have 3 positively charged particles, a proton, and another proton, so it's plus, plus, and plus. And then you also have 3 negatively charged particles, an electron, and another electron, so a minus, and a minus. So let's say that your nasty little brother just comes in and just takes away one of your electrons. So now you're left with more protons than you have electrons. And you want to know what charge your atom has right now, because it's definitely not neutral anymore. So you start calculating. You have 3 positive particles and 2 negative particles. So positive 3 minus 2 will equal to positive 1. So you have a charge of plus 1 in this atom, of course. But if your nasty brother hadn't taken your electron, you'd still have 3 positive and 3 negative particles, leaving you with a charge of 0. An atom with a charge of 0, it's called a neutral atom. But your brother is very nasty, so he comes in and takes your second electron. Oh my gosh, now you have 3 positive and only 1 negative particle. And that will leave you with a charge of positive 2. But then you realize your brother isn't nasty. He is horrible of a creature. So he comes in and takes your last electron. Now, what now? You only have no electrons. You have 3 protons and 0 negative particles. So you have a plus 3 charge. How dare he take all those electrons? So you went ahead and complained to your mother, so she returned your electrons. But she didn't know how many electrons your brother took from you, so she also took some of his electrons and gave them to you. So now you have actually more than 3 electrons. Now we have 3 positive and 5 negatively charged particles. That leaves us with a charge of negative 2. I'm telling you right now, this is boring. I'm forced to talk about this. But here we go. Isotopes. We have a nucleus, and it has a certain amount of protons and a certain amount of neutrons in it. We can take a closer look at this. So we have a certain amount of protons and a certain amount of neutrons in the atom. Now we can add or remove neutrons from the atom, and it will change the isotope.